So, Assalamualaikum warahmatullahi wabarakatuh and good day. So as for today, I'll show you how to use LC3 software. So this is the installer. You can get the installer from Open Learning. I already uploaded this installer over there. So just double click on it, okay, and run. So this installer, this folder will be unzipped, and after you unzip this installer, you will get the list of files and folders like this. So we are going to use LC3 edit and simulate. So I'll show you how to use LC3 edit. So I double click on it. So this is the interface of the software. So we use this interface to type our program code. So let's say this is the example of the program code in assembly language. Take 0, and then again at R3, R3, R2, and then at R1, R1, hashtag -1, branch positive, again out, and then label 1 dot plkw1, label 2 dot fill x0006, then dot end. Okay, let's say this is our program code in assembly language, and we want to convert this code into binary format. So here we have 3 buttons. Okay, this is the assembler for the code. So if we type the code in binary, so we can use this button. This one is the button that we use if we type the program code in hexadecimal, and this is button or assembly button that we use if we want to convert the assembly language into binary language. So we will use these buttons to convert this program code because we type this program code using assembly language. Okay, we just click on the button. Okay, first of all, we need to save this file first. So I've already created one folder here, so it's empty. So I will save the program code into this folder. So the way how we can save this file is like this. We use double quote here, and then we named the files. For example .esm. We use .esm because the code is, we type the code using assembly language. So we use double quote to close the name, and then we save. So we already have one file here. So the type of the file is assembly file. So we can open up this file using Notepad. Okay, so this is our code. So we close this, and then okay, now we try to assemble this code. There are 2 errors. So the first one is here. I double click on it. Okay, this is the error. Oh, I have syntax error over here. Should be R3. And then I think this is also an error, R3. So we save and we assemble the code. Okay, so there's no error. So there are 2 parts here, pass 1 and pass 2. So if we look at the folder here, so there are 5 more files that will be generated after the assembling process is finished. So the first pass product, this is the first pass process, the pass one process. So the production of this process is a symbol file. So what is the content of symbol file? So a symbol file contains of a symbol together with its address that is associate to the label or symbol. So we can count this address manually. So here in the code we have 3 labels, again, label 1 and label 2. So the address for label 1 is again, okay, you see here, again is 3053. So how can we get this address, this value? So we just count it. So the program will start at 3050. So this one is 3050, this one 3051, 3052, 3053. So the value of again is 3053, and then 54, 55, 56, 57. Level 1 is 57, 3057, and level 2 is of course 3058. So this is how we count the page address or the PC program counter for the label manually. So this is the symbol table is the production of the pass 1. So during the pass 2 process, this one, so here this code will be converted into binary language. So we can see the code here. Okay, see the binary file here. So we just open it up. So tada, this is the binary code for the assembly language that we just typed the code just now. Okay, so this is the binary language for the code. So if you want to see the hexadecimal language for this program code, you just need to click on the hex file here, hexadecimal file. So this is the code in hexadecimal, or maybe you can click list file here to see all of the language. So here we have the address or the PC program counter or the page address, and this here we have the hexadecimal code. This one is binary code, and this is an assembly code. Okay, so this is how we use LC3 edit to convert the assembly language into binary code. So you can use this software to check your answer or to do the exercise. So this is how we use LC3 edit. And next I will show you how to use LC3 simulate to trace the code. So LC3 edit, LC3 simulate. Okay, simulate. So this is the interface of the LC3 simulate. So at the top we can see the content. The simulate. This software will show the content of the register, so we can see the content of the register directly. So this is a register R0 until R7. So this is the content of the register in hexadecimal form or in decimal form. Same goes to PC or page address value or address value. It starts from x3000 in hexadecimal, or in decimal the value is 12,288. So let's say we going to use this simulate using our code just now. So first of all, we load the OBJ file. If you look into this folder, we can see one of the folder name is OBJ file. If we open up this, okay, this is how it looks like. Okay, so OBJ file is an executable file. So the OBJ file seems similar like library. So we just import the file. The processor or the CPU will use this file to execute the operation. So we import the OBJ file here into LC3 simulate. So if you look at here, the address is the initial address is x3000, but after we load this program into LC3 simulate, because of our code is start from 3050, so the OBJ file will be loaded into 3050. See, 3050. So we can run this, we can execute or we can trace this code one by one to see how the content of the register is changing. So we just use this button. Okay, see the first the initial value of the register is 0. All of the registers are 0, and then we just click this. Okay, it's already changed to 6. Why? Because for this line 3050, the value of label A is loaded into R1. So what is the value of label A? You can see here the value of label. Okay, this is the value of label 2. Label 2. So we put 6 into label 2. So when we execute this line, the content of label 2, sorry, not label A, label 2 is copied into R1. So 6 is copied into R1. So that's why the value of R1 is 6. And then we can trace in. Okay, now the content of label 1 is copied into R2. Still 0. Okay, still 0. Okay, nothing is changing. Okay, now the value of R1 is 5. Why? Here, this line of code deduct the value of 1 from R1. So just now R1 is 6, so 6 minus 1 is 5. So the new value for R1 is 5. So we trace again. Okay, try to guess. They are looping over here. They're looping. I mean the basic construct here is looping. Okay, here we have sequential basic construct, and here we have looping or iterative basic construct. Again and again. Here we have an iterative basic construct or looping. So I think this loop will be stopped. I mean, okay, the loop is stopped if the value is not positive. Now the value is still positive, 4. So we trace again until the value becomes 0. Okay, and then 1. Okay, 0. Okay, and then the program will be halt. Okay, the program will be halt after the value of R1 is 0. Why? Because if we look at the condition here, the process of looping or iterative is going to be happen if the value is positive, and the process of looping will be stopped if the value is 0 or negative. So now the value is 0, so it will be stopped. You do remember the condition is n, z, and p. So we can set the value according to our own needs. So that's it. That's how we use this software. So good luck, and Assalamualaikum warahmatullahi wabarakatuh. Bye bye.